Welcome to orthogonal trajectories. So a curve is an orthogonal trajectory to a family of curves if it is orthogonal to every curve in the family. And orthogonal here, meaning they have perpendicular tangent lines at their intersection points. So when we want to find orthogonal trajectories, the trick is to first find the differential equation for the family of curves. That way you know the slope of the tangent lines. You want to rewrite it as y prime equals some function f of x and y. Then you find the negative reciprocal slope for a perpendicular line. So write a new equation for perpendicular slope, or so that would be y prime is equal to -1 over f of xy. And then that should be your differential equation for the orthogonal trajectories. So then you solve the new equation. So let's consider orthogonal trajectories to the family of parabolas whose vertex is at the origin. So we're looking at y equals cx squared. So the first thing again is to find the differential equation. So we're going to just differentiate the equation with respect to x. So differentiate y equals cx squared with respect to x. And we get y prime is equal to 2cx. Now we need to do our substitution. So we have this first equation for our substitution. Y equals cx squared tells us that c is x squared. Sorry, c is y over x squared. And then we can substitute that in. So we have y prime is 2cx is 2 times y over x squared times x, where we get, so we get that y prime is 2y over x. Now the next step is to find the perpendicular slope. So if we find the perpendicular slope, we will do y prime is negative 1 over 2y over x. And this becomes y prime is negative x over 2y. Then we solve that new equation. So this is a nice separable equation. We have y prime is negative x over 2y. That tells us that 2y times y prime is equal to negative x, right? It's separable. Integrating both sides, we have the integral of 2y dy is equal to the integral of negative x dx. So on the left-hand side, we have y squared. On the right-hand side, we would have negative 1/2 x squared and then plus c. And so this would be, if we rewrote this in a more traditional form, 1/2 x squared plus y squared is equal to c. And this is a family of ellipses. So that kind of makes sense if we looked at a bunch of parabolas. So here's our family of parabolas. If we look at ellipses, or ellipse, we draw sort of perpendicular, 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 perpendicular. That sort of makes sense that we would get an ellipse if we keep drawing ourselves perpendicular. So our parabolas that go through the origin, or that have vertex at the origin, have a particular family of ellipses as their orthogonal trajectories.